Okay, so the Hercules Great Wall that has been around since 2013 or has been discovered since 2013. There have been people that kind of like argued like what is it really and if it even existed because of how big it massively is. So I've just kind of wanted to make some videos kind of like talking about it a little bit more, maybe some stuff people don't know about it. So basically, if you don't know, it is one of as of right now, it's the largest structure that is known in the universe that I could find. I wouldn't be surprised if it's even bigger than it is right now, because it's hard to measure something, that, especially as big as it is, and we'll get into this. And how far away it is creates that optical illusion that maybe it's even bigger than it really is. So you have this structure it's mostly conducted of basically radiation, just like you'd expect everything else in our galaxy and universe to be constructed of. It's just a bunch of galaxies that are forming together too, that are cluttered together. And it's basically, I mean, if you want to go by the observable universe, which is like 96 billion light years in diameter right now, it's like basically 1/10 of that size, nearly. If we were to round it up to 100, the observable universe being 100 billion years, but it's like, I mean, something that's like 10 billion years like long. So that's so basically light travels at like 300,000 kilometers per second, and it could be even faster than that, but again, this is all just what we know so far. And so if you were to take 1 billion light years, let's just say, you would basically have, like, because 1 light year is 5.88 trillion miles. That's basically how far light can travel. I think I think it's like 186,000 miles per second. I believe if you want to convert it to miles, but 1 mile is 5,280 feet, by the way. So it's basically just a bunch of longer measurements to convert into something else. But basically, the point we're getting at is you have this structure that's so large and it's so big that it just has to mean that it's like a box being stacked inside another box. You find like these big structures in the universe, and they're mostly made up of the same stuff we already know of. Gases, radiation, energy, planets, galaxies, moons, asteroids, comets, some other stuff we probably haven't even discovered yet, like subatomic particles that make up that. It's basically just an infinite structure, and it just goes to show you. It kind of made me really think. Like every time I make these videos, like in comparison wise, try to figure out like two things. What does everything make up, and how far does it really go as far as like infinity? Because when you really think of the concept of like the universe, by the definition of the universe, and there's a lot of stuff out there that by definition people would be, it's kind of outdated, because there's a lot of stuff that doesn't, like, a lot of news articles get published but you don't read about them because they had to confirm them, or but there's all these theories that pop up. And one of the more interesting ones has always been, like, with people, is like there's parallel universes, or basically an infinite number of universes that each to their own are in infinite dimensions. And it really got me thinking, if there really is nothing in between the space here, like, because you think about it, like, even if you were to take like the Hercules Great Wall and go inside of it, what galaxy would you currently be in? And then as soon as you leave that galaxy, what other galaxy would you be in? Like, if it's all like inside something else, so technically it seems like everything in space kind of like border laps, sort of. Even if it looks like there's a cluster of nothingness between every solid object that's flying around in space. Like, I'll give you another example so you can kind of see what I'm getting at. Because everything in space moves and everything creates its own energy, and the faster things go in space, the more energy it creates, the more mass it can also create. And that's what a lot of people underestimate here, because one of the things people have always argued was they believe that the universe is infinite. Same thing with some of these structures. They're moving in space, because you what you see is like all the stuff that makes it up, but until you zoom into it, you really see what makes it up, like the galaxies, the planets, the solar systems. But because it's so far away, you really don't get a good glimpse of it, though. Like, what really makes it up? Like, it'd be like taking a telescope, looking up into space, and seeing like what looks like nothing, but if you just zoom in a little bit, you can see something. So it's just a further, it just kind of, and that's what gives off that optical illusion that some things are smaller or bigger than they really are, because you have the size of the object and the distance that you're away from, the coordinates, they call it. You know, it's very interesting actually how science has really taught us a lot of cool things, and some of the stuff that we really have to really ask ourselves, like, you know, what is really going on in this universe that we don't see? Because obviously it's almost like, you know, we think we know everything, but when you find that one thing that changes everything, you just kind of don't look at life the same way. It's kind of like staring off into the void, the universe in this case, and it's just complete silence. But you're just thinking at the back of your head, like, what's gonna happen next? What's going on? You know, it's like in a horror movie. You know, something bad's gonna go wrong, but they don't show it. You know, just messes with you, creates paranoia. What's gonna happen next? I don't know. So yeah, you know, you have this big giant structure that has a lot of galaxies in it, probably even more galaxies than we think it does. Stretches roughly 10 billion light years. So the light years basically, so you basically would take 10 billion and times it by 5.88 trillion miles. So if you wanted to really get an idea. But what's really interesting is they say that, like, if I remember correctly, they say it was like 14, 15 billion light years away from Earth or something like that. So if that is true, then it's literally the distance that thing is from here to this planet almost. But times it by like the 1.5-ish. You know, maybe a little under, but that's just pretty cool to think about that. You know, we can think about this stuff and find stuff like this. You know, it makes me wonder what else is out there. You know, because it reminds me, like, earlier this year we found this giant arc, not a giant arc like, you know, like you find in religion, but a giant arc as in, like, you know, like measurements and all that. There was this giant arc that was discovered in space, and they said it was too big to be where it was at. Like, they found this clutter of galaxies together. Now, mind you, it's like basically like, you know, bigger objects inside smaller objects, and then, you know, it just goes out the further you go. So you have a galaxy, so you have like planets that are inside galaxies, and then galaxies that are inside other galaxies, and it just basically becomes like higher subgrouping classifications, just so you're not confused. So basically, these objects that we had found were so big and large that they consisted of so much stuff that we were still trying to figure out. And then so they found like this, it was like 9 billion, or no, it wasn't like 9 billion. It was like something, it was 9 billion light years away from this planet, I believe. But it was like 3.3 billion light years all the way across in diameter or something like that. If I remember that correctly, if I got those, I know those two measurements were accurate, but it's like, I'm trying to think if that's what the numbers were for it though. So it was, something was 9 billion and the other was 33.3 billion, but whatever it was though, it was so large that the planet itself, or the structure itself, made scientists really think that maybe we really are looking at like how much we really don't know in the observable universe as well. Because keep in mind, if you don't know this, there have been debates where they've been going back. Now they, like, back in 2000, I think it was back in 2016 or something like that. Or maybe it was 2020. No, it had to have been sooner than that. I think it was 2016, 2018, so somewhere around there. They said somewhere in October that they made this idea that there were like 4 billion galaxies, or 2 to 4 billion, or 2 to 4 trillion galaxies for every 96 billion light years in the universe. And if that was true, it really made us realize just how small we really are in the universe. And so, but then there have been debates where they kind of came out and they lowered the number to like 200 billion galaxies, which is still huge. But personally, I don't know if, like, maybe it just might have been a bunch of false positives, because it seems like every time we reach a big number, you know, yeah, it's easy to really look at it and say maybe that's too big, maybe that's too much, maybe we're overestimating it. But if you really do think about it, because some of these objects are so far away, and they use supercomputers to count stuff within a certain range, that's just how they kind of done it for years, if I remember correctly. I wouldn't be surprised that it's kind of hard to really determine what is, you know, they do it based on like graphical dots and all that. It's still pretty impressive that someone's trying to make an attempt to figure this out, because this is really complicated for where we're at in the universe. But based on our data though, there seems to be way more galaxies than we can comprehend either way. So if you have like an atmosphere, you have a structure that has, it's like at least 10 billion light years, for example, and that stuff, you know, and you start like really being able to dig around and see what's in it, you're going to have a lot more questions than you do answers. But more importantly, though, what it seems like, at least, is that maybe these structures, like everything about them's bigger. How many galaxies, how big those galaxies really are. Because I've learned, like, as I've learned and analyzed some stuff on this channel, like, for example, I would say that the stuff that's closest to this planet would be the easiest stuff to really kind of configure, because it's, like, all right here and it's the closest, but it's still far away. Like, even our galaxy, you know, there have been times people have said that our galaxy was, like, at least 100,000 light years in diameter, and then there have been speculations, hey, maybe it's actually bigger than that. And then you had like some of these articles. This is one that caught my attention like about a year ago almost. You know, it was actually like there was a scientist that came out, a group of scientists, and they claimed that they actually think they might have found like the edge of our galaxy, one of the edges. And they were measuring even the halo and all that, and just a certain distance of it. So they speculated that, hey, if the halo was much bigger, it has to be at least bigger than 100,000 light years. And even bigger than that, you know, there was speculation that, you know, maybe it's like 2 million light years in diameter or something like that. And well, it was really lower to 1.9 million, but it's like, you know, you look at some of the stuff these scientists are saying, it's like, well, wait a minute, you know, if these really are, now keep in mind, because we're living inside the Milky Way galaxy, you know, we can measure it because we're inside the galaxy, like a lot better than, there's no like illusion of distance, it would seem, as compared to like something that's like billions of light years like in this direction, and even if it's moving fast or wherever that's going. But you know, but since we live in this galaxy, we can say, hey, you know, how big is the Milky Way galaxy if we can just find one of the edges, you know? And so we've speculated that, hey, you know what, if we can find the edges, then that basically means we can draw the circumference in our head, what it is. And basically, you take the diameter times it by 3.14, 3.14 pi, and there you go. You know, so like if it was not, like I'll give you an example, you know, so like if our galaxy was like 1.9 million light years, you would times it by 3.14, and you would at least get, it'd be like at least 6 something, you know. No, wait, what is it? 1, 2, 3, maybe a little bit, no, maybe a little bit more, like 5.9 or something like that, maybe a little bit less than 6, but you know, but basically you get my idea. You know, it'd be 6 million light years it would take to travel around our galaxy one time, you know. And that's crazy. That's crazy to think that if such a thing, like if our galaxy could be that big, what about the bigger objects that are flying around out there? You know, I believe that the Great Wall, not the Great Wall of China, but the Great Wall, the Hercules Great Wall, it can be significantly bigger than it already is, because even though it's far away and we might not be able to just go there and observe it and try to think like, hey, you know, what's in here, you know, maybe it's possible that maybe there are life. It really just goes to show you that maybe we're already answering more questions that we're, you know, really still like in question about. You know, we're still trying to figure out, like, do aliens exist? And there's people who do believe, you know, I do believe, you know, because there's a lot of other planets out there. You know, we live on this planet. Why wouldn't there be another planet out there that's got some sort of a civilization? You know, there's so much to the universe we don't know. It's like a giant zoo that's been created by something else, or maybe it was created by itself. Who knows? And then there's just other dimensions out there. Not to mention, you know, but here's something else that's interesting to think about, and this is going to be like what we'll talk about in this video for the rest of it, though. You know, talking about like the idea that everything is inside of something else, it seems like, and there's no borderline. It seems like where there's like a cluster of nothingness in between. It seems like it's still something, though. So like if I was to leave the solar system, I would immediately be in another solar system. Or would I still be like in a cluster of like nothingness before I enter the next solar system? You know what I mean? Because like there have been scientists that have talked about, you know, like I'll try to explain this the best I can. So like a galaxy, for example. And it really depends on what kind of galaxy, because there's more than one galaxy, and there's more than one different kind of galaxy, depending on how it was originally formed back in its cycle. So if there is any reason to believe that there's obviously more than one star or more than one galaxy, it's that they formed based on gases, energy, and so all the stuff is just holding itself together somehow. You know, the energy is there, and even if it burns out and becomes something else, it will merge into something else. A good example is like the Andromeda galaxy. That is said to be like emerging with our galaxy. And so I think the Andromeda Galaxy was actually said to be even bigger than ours. And if I remember correctly, the Andromeda Galaxy might even be even larger than what we previously thought. Like if they were saying that our galaxy was like if our galaxy is like 20 times bigger than what we originally thought it was, and I believe it, maybe it's even bigger than 1.9 million light years. That means there's got to be more stars, more mass, more, you know. But that also means that there could be other stars out there that are, like other galaxies such as the Andromeda Galaxy that could also be more stars, more gases, whatever is in it, whatever makes up its, its mass, rather, its solar mass. So if we were to say that, for example, it does make you think, like, how many more possibilities are there? How many other structures could we possibly find that we might not be aware of? So, yeah, you get all these crazy ideas that could possibly exist that we don't see, that could very well determine that there could be, I mean, heck, you could even have, like, you could probably have, like, other civilizations that travel the universe, and maybe they're not even from their solar system. Maybe they're not even from their own galaxy. Maybe they found a way to traverse to another galaxy, like fourth dimensional beings, for example, like from another dimension. Imagine something like that. That's actually pretty cool. But it does make you wonder, like, how much progress would one have to be able to become what they sought out to be, if that makes sense. Or maybe they're so damn, like, they're immortal. Let's say there's some kind of a civilization out there that's basically like a creator, a god of some kind, or a goddess, and they're able to just go wherever they want, and there's no repercussions whatsoever. Like, they'll just survive no matter what, and then it's like, so where do you end up? If you have that, like, that kind of ability, you could travel to the universe, to the other edge, well, eventually at some point, as long as the universe slows down, you're still going to eventually run into points that haven't really been seen before. Other dimensions, other planets, other civilizations, rather. Or maybe you just run into the ruins. You're going to eventually see things that a lot of people don't see. So that'd be actually really interesting if that's true. If that's what science fiction has really taught us about, like, traveling through time and space and time warps, or even just having different powers, rather. Like, if you're able to somehow overcome, like, what makes the universe so dangerous, then you're basically, like, better than the universe up until that point, unless you can find something else in it that could like actually kill you. But, like, if it wasn't for, like, the objects and how fast they're moving in space, but because everything's, like, all far apart, unless you get into, like, to something complex like the asteroid belts, like, things hitting each other and then just go flying out of their orbit, or maybe they get forced out of their orbit by a more complex acceleration force, such as, like, Jupiter's magnetism, for example. Scientists to this day still can't understand why Jupiter is able to do stuff like that, it seems like. And some scientists believe that maybe it also has a lot to do with just, again, other objects colliding with each other, screwing up their orbit patterns, and then they go flying towards, like, Venus, Mars, Earth, all sorts of crazy things. The moon. Yeah, it's very interesting, actually. Or even comets from, like, from the Oort cloud, like the perimeter of our solar system. Sometimes there's comets that somehow find their way all the way up to where our sun is, and it's like, wow, where did that object come from? Some objects that probably weren't even from the solar system, but maybe the next solar system over. And yet here it is. It's always the mystery about life. It's always about something, but there's just so many details we can't answer. It's always easier, like I've always told people, it's always easier to ask questions than it is to, like, really say, hey, what is the answer to this? We don't know. And that's what's scary, Can be, at least. But, so, basically, we have, so, like, up until this point, we could have, like, these celestial objects that are so big that are, like, again, like, other galaxies, other universes, and it leads me to really believe, like, even, like, black holes have to lead to, like, other dimensions and all that, because, even, and it goes back to, like, the whole idea, like, another universe, like, what would happen if one universe merged with another universe? Would it have, like, the same effect as, like, a black hole does, where, like, it just becomes an even bigger black hole? Because, like, if a universe is just basically a giant void with whatever's inside of it, you're basically, like, already, like, two giant voids that just merge together anyways. So if they can do that, if they haven't already, then it really would show us that we really can underestimate what the laws of nature have really provided for us, you know. And it really does just go to show us that we really don't understand like everything around us for whatever reason that it's all intent and purpose was. Again, progress is what I would call it, but maybe somebody else might have a different idea, and I'd like to hear that too. If you have a different idea, well, you tell me what you think about that, because that's something I've been still trying to figure out. You know, what do you guys think the meaning of life is? You know, I always thought it was to become somebody. You know, to do better. You know, to wake up every day and to become better than what you were doing like the previous days, or just to sit down, or just to enjoy it. You know, smell the roses rather. So as long as you're happy, you know, that's all that you can ask for in life. But that's really what I would say matters the most. You know, you should have goals in mind to keep you busy, but you know, but if you're as long as you're happy, that's really the one thing that people should really think about. But while we're here in this world, you know, rather than just thinking about the same thing over and over again, you know, I always like to just kind of open my mind up to like things that we don't see, because this is stuff that is like an opportunity. You know, you try to understand like what a scientist discovers, and it's like, oh, okay, somebody discovered something, you know, but what about it, these things that we don't know about them, these planets, these galaxies, these other universes that could exist, you know. And it really does become a lot more fun, because you really can see like somebody's trying to make an attempt here to really find something that maybe nobody else knows about, you know. So anyways, you know, if black holes, like, okay, so if you're someone who believes that there was a big bang at one point, there have been some arguments lately that people have been saying that it maybe it was never singular to begin with, so it could have happened more than once, basically. And I wouldn't be surprised, because I mean, I believe like quantum physics states that, you know, nothing is still something and everything in space, like Albert Einstein's theory of relativity, which is actually true, believe it or not. He stated that, you know, he believed that everything in motion creates energy. Everything in space is moving at such a ludicrous speed, as you would have you believe. But what happens is when everything creates, you know, like such an acceleration to begin with, it creates more energy. And it's kind of even more complex, because the further something goes in space, it doesn't always travel at a fixed velocity, meaning like it's not going the same speed. In some cases, it could go faster than what it is. So if that is true, and this might actually be the help of some other stuff in the galaxy, like, you know, like hypothetically like dark matter, dark energy, or even dark flow, mostly dark flow, if it does exist. There have been theories, people have speculated that dark flow actually would help out significantly with the progression of the universe, because it could actually get the universe to accelerate much faster than light itself could travel. And so basically, in other words, you know, they might say that, some people might say that there's nothing in the universe that could ever be faster than the speed of light. But while light is really fast, there have been arguments to state that maybe light itself cannot travel faster than the acceleration of the universe. Now, if the universe is infinite, that doesn't necessarily mean that everything in the universe is already infinite. It could just, it's building its way into it still, but not to mean like it's finite and it doesn't exist then. It's kind of confusing. I personally believe that the universe is kind of already infinite, because it just seems like no matter what you do, that everything has already been kind of done once already, it seems like. As strange as that sounds, but then again, you know, life is stranger than fiction, so even if it doesn't sound like it makes sense, you know, it might. So in a way, I do believe that the universe is infinite, and it's still able to expand, kind of like how we're born into our world, for example, and we're still able to, you know, do things ourselves on our own free will. Again, not bringing any religion into this, but but you know, but people could do their own thing, accomplish something that nobody had done before, and there you go. You know, so it wasn't already done before you seen it. It was, you know, you did it and succeeded and turned it into something. You took something that was nothing and turned it into something. So it's still proof that you could have those two things exist. So even if it did exist in like another universe, let's say, then it could still exist in this universe, you know. So you could still do something more than once, basically, as strange as life can be. But we can definitely prove to ourselves that yes, we are still capable of making progress like that. You could take an idea that nobody's done, turn it into something, and then here you go, right? But what else was I gonna say? There was something else. Oh yeah. So if we are to believe that the universe is infinite in progress, let's just say, and there's definitely more structures that could exist that could very well implement, that maybe we not only not know it, not only do we not know everything, but we also have yet more to learn. But it also is proof that that is proof right there, that we should be able to look at everything in the universe and say that there is reasons to believe that there's more than one universe, and there's more than one. It's kind of like we're just reverse engineering it. People have speculated. They say, well, how do we know that there's other universes out there? Well, okay, we live in one, so okay. But what happens? What about energy that can't be destroyed? You got black holes that you got people asking questions like, what exactly is a black hole? It sucks something up one side and it sends it somewhere else. Well, it's like, well, where does that go? Another universe? So is it possible that a black hole not only leads to another universe, but at the same time though, does that really mean like it's going to like outside of our universe? Like just to another universe? And I would say yeah, if that is true. It creates a like and it's even more confusing because like there have been some even more weird theories that are like I don't think too many people can really wrap their head around this. I think you really have to be like you have to have a wild imagination to be able to make sense of some of this stuff. But like one of the ones I remember reading was they said that a black hole because it moves in space, that it doesn't necessarily lead to the same universe that it originally opened up to, assuming that that's how it works. So if because like usually when you think of it like when you see like a hole in something, like a hole in a shirt, for example, that same hole that's in your shirt is still like on the other side, so it's still the same hole. Does it still lead to the same spot though? Well, it depends on where that hole's at. Like if or to make something even more sense, like say you had a hole in your pocket, for example. Up until a certain point, like whatever's in that pocket would fall through that hole if it was big enough. So it's still falling through the same hole, but it might land somewhere else. But depending on how, like, the logic here is like the same thing with black holes. It might be the same hole and energy might get sucked into it, but as it's moving through space, though, some people have speculated because it moves in space, is it necessarily leading to the same universe? Or is it spitting it off? Like, think of it like every science fiction movie that you've seen, where, like, they get sucked into a wormhole and they get spit out somewhere in the space time continuum. And, and one of the quirks is it's the moment that they get spit out that they don't always end up in the same location. They end up in a different location because that's where they just got spewed out. So if they went through the same wormhole and the universe is moving, I mean, I wouldn't be surprised if the universe was moving, but as well as like the black hole itself is moving inside the universe, that leads to, like, let's say another dimension, and that spits you out somewhere. Because black holes move, does that necessarily mean you end up in the same universe? So can one black hole be creating more than one universe? From what starts out as a singular point to now what becomes like a multiple point. And it wouldn't surprise me. I would say, yeah, that makes sense, because if that is true, we have proven that if dimensions can exist from a singular point, you can create an infinite number of dimensions because, well, first of all the dimensions could be going in an infinite number of directions in a singular point, but eventually those will break off and go and form another multi-segment point from a singular point. It's very complex, but it's basically it would prove like how like the third dimension could evolve into the fourth dimension could evolve into the fifth dimension, the fifth dimension could evolve into the sixth dimension. You get the idea. But it's like, but let's just keep it simple though. Okay, so we live in the third dimension. Okay, so basically there's three forms of dimensions. It's height, width, length, and width, if I remember correctly, not base. But if we were to go into the fourth dimension, basically you would have to really say, well, first of all, what's the other line of dimension that they added, and does that work really? So if somehow, I would say that probably most scientists are right when they say if we were to go to the fourth dimension, we wouldn't be able to perceive it because it would look completely different than what we could. It would be so different that it would cause nauseating material headaches and probably possibly throwing up, because it would be like everything's all trippy, and how you're not just having a massive hangover rather than some kind of You know, you just went to another dimension and it just doesn't look, it looks different, but it doesn't look the same though. And that's even before you start considering what's even in that dimension, you know. So it's strange to think, you know, because even like in the third dimension, you know, you got people that can, you know, they see different colors, and there's and here's something else that's even stranger to think about. You know, you think about colors, the color spectrum. You know, there's some people that can't see certain things. Maybe they're what we call them colorblind, but maybe what they see is actually what it's truly, what the true colors of it are, and maybe everything we're seeing is a different color that we shouldn't see. So maybe, you know, I think really at the end of the day, I think there's just so many things that, you know, there's so many things that we think we know that we really don't. And then, you know, for the things that we don't know, well, we just haven't found those yet. But it just goes to show you, like, you know, you start asking the right questions and you're really going to stop what you're doing, and you might even confuse yourself to the point where now you can't even really stop thinking about it because you just came to that realization. You know, it's some weird stuff in science. It really does make me wake up realizing this every day. But so yeah, that's how we go from the Borealis and its size to, like, you know, the complexity of the universe beyond that, and how many things we don't see with it. Because if, you know, if it was created by something, or an infinite number of creators, if let's say that is true, then it does make you think, where do they come from and how do they come to creation? You know, again, so many things we don't know. I'm talking all possibilities here. I'm not just talking like one thing. But I don't know. I don't know what I believe. I only believe what's true, and definitely the universe is a wild and strange place when you think about it. There's just so many things waiting to be discovered, and there's been so many things that people think they found, and maybe they found something else totally by accident. You know, it's crazy how things, I've always said too that it's not the fact that things happen that's strange, it's just the way it can happen that's strange. You know, you can go on like on an expedition, for example. You know, like one of my favorites always was, you know, like how the Titanic was originally discovered, the original Titanic. You know, they went out on they were trying to find something else, and they ended up finding something that a lot of other people were still trying to find to that day. And they didn't have any idea where it was at because they were looking in the wrong spots. And eventually, so somebody goes on a deep sea expedition trying to find something, and, you know, maybe just going down there, just, you know, go see what they can find, right? And then sure enough, they find something that, well, totally by accident, somebody else found, that somebody else was trying to find that they could not find, you know. But it's interesting though, it really is, to think, like, you know, how life really does work. It really is. So the strangeness of the universe included, it really does make me think that maybe there's just, you know, maybe not just all the things that we don't think of, but it does make you think, like, what is life, you know, if we still haven't found everything. And I know we never will find everything, but it does, you know, but it always gives you that sense of accomplishment, like, to really wrap your head around such a complex, singular, infinite point. And then meanwhile, it's like, you know, if our universe is inside something else and there's nothing like between those dimensions, let's just say, like, nothing again, going back to the nothingness in between, everything kind of bisects somehow, like, meaning like it touches. So if our universe is overlapping into another universe, does that mean it's just one big giant universe inside a bunch of multiple bubbles, as they call it? But keep in mind, when they say the term bubble, they mean universe. So this is what I got it down to so far. So if we live in a dimension, so if our galaxy is obviously huge, obviously. So you have roughly 1.9 million light years at least to discover and go to other planets, if somehow you could travel through space and see what's in front of you, because the universe is much darker than you think it is, and it's that would probably be the one thing that they don't explain a lot, even in science fictions, because what a lot of people don't understand is, you know, you hop into a spaceship and go flying through the universe, you know, you're traveling at really fast speeds, but even more realistically, you know, the light in front of you doesn't mix with dark matter. So the stuff that we don't see, you're going to need something that's super concentrated or something super heated, rather. It's one or the other. I can't remember. Like, because when people use the word concentrated, I don't know if they mean like it's really like frozen or something like that, or if they're referring to it being like heated, though. So the universe is dark. Not just dark like as in like evil, but I mean like, or chaotic, but you know, it's just like the light fixture on it, you know, because most of it is energy, but most of us still don't know what dark matter really is. You're looking at it's such a material that requires like more than just like light amplification or luminosity. You basically would need like some kind of like an enhanced visor to be able to look through it. And what kind of visor would actually be good in that case? You know, it's actually something to think about. Whether it's maybe something that can identify dark matter, and then it can show off like like everything around you without giving you like some kind of blindness or some kind of headache to endure, you know. Like so like dark matter is said to be like some kind of like, not, I wouldn't say hypothetical, because it's obviously still something, because nothing is still something in quantum physics. I still think that, you know, if dark matter is what they say it is definitely going to be like some kind of radioactive kind of material. It's kind of like think of it like if anybody's ever played Metroid Prime, you might remember like the phazon and all that. Like it's like this blue dark element, but you could see it though, you know, because you were supposed to, and it was radioactive, sort of. It would kill you basically if you touched it for a long period of time. So you had to handle it in a super concentrated. That's how the space pirates had to handle it, because they were mining that stuff, but they also had some of their own units get killed by it because they were in it for too long. So it caused like all sorts of weird radiation. But dark matter is kind of like the same thing, though. I mean, while space itself would kill you itself because of how cold it is, but keep in mind though, some of the stuff in the universe isn't necessarily always necessarily hot, you know, because you got the planets and the stars that are still orbiting and fast. And how fast can something create friction in space? So you basically like, but if you were talking about like some dark matter, certain parts of the universe are like, it's like negative almost 500. It's like 462 or something like that. So somewhere around there. Forms of radiation. But if we are to believe that the universe is capable of, let's say, being like something like that, hot or cold, in this case it would be cold, you know, you would have to figure out like how to traverse through that dark matter, like, because you can't see it, light doesn't mix with it, and you're going really fast. And not only that, but it's like then you have like every other object in space that's moving at ridiculous speeds, like rocket speed, basically, like maybe 600 miles per second or something like that. You know, like we're talking like rockets, like it's like Mach 1 or Mach, you know, kind of like F-Zero sort of speeds, you know, going super fast basically. But instead of an hour, but rather than hours, it's like per second. So no, there's no weight in light. They say there's no weight in space because unless something's pulling you down, that's how we measure weight. But basically, everything in space is just moving fast in this infinite void. It's just going somewhere. It's happening, you know. As Bob Ross would say, you just let it happen. So it traverses in some kind of a weird way, but it's just, you never know where it's going to end up. So if that is the truth, and that's how if that's the nature of acceleration that we have it down to so far in space, then basically, yeah, you know, you would have to find a way to travel from planet to planet and other objects rather without running into other objects. But first of all, you'd have to be able to see it, you'd have to be able to build it, and you'd have to be able to pilot it basically. So if you can do that, then yeah, you wouldn't have to worry about like your solar shields getting destroyed by like every rock that, like, you know, like every time they go in warp speed and all that. It's funny because like what if they hit like all the planets along the way that are in that straight line or something, or like, or maybe they just go so fast they phase right through it like a photon blast. I don't know. Like that's stuff that we, you know, if you really think about it, there's a lot of things there's a lot of contradictions you could run into, but maybe there's something we just don't understand there that, you know, maybe science fictions like Star Trek have been able to figure out, or even Stargate SG-1 for example. I got one of my friends that always keeps reminding me of that show. So, or Firefly, if anybody remembers that one. You know, just some of them I forgot. Some of these shows I forgot about over the years, but you know, I know there's somebody out there who probably remembers these. And I just think it's pretty cool. Like, you know, you think about like a civilization traveling through space, all the stuff that they come across, and all the mining resources that they can find. If they can just get out there and get it and bring it back somehow, you know, you create like maybe right now we talk about how like our galaxy's kind of got like an economy of some kind, and meanwhile maybe there's a civilization out there flying around through space, and they're capable of taking stuff and going to other planets and selling it to them, you know, kind of like an economist and an opportunist, but just with better technology and opportunities. Very interesting stuff to think about, you know. It really does go to show you that, you know, how big the universe really is and just how small we really are. You know, we seem to think that, you know, a lot of us seem to think that we really have it all figured out, but it's just because either people don't want to try new things, or maybe they just haven't questioned that yet. What is out there waiting to be discovered? And so it makes me really realize that, you know, even when it looks like nothing's there, there could be a whole lot of something there. So something to think about. But yeah, basically the Hercules Great Wall is basically 10 billion light years of opportunities, of discoveries waiting to be known, whatever's in it, and whatever else is in it, and however else bigger it is. If it's bigger than 10 billion, then, you know, 10 bill, whatever size it is. But it's very interesting to think about, to think that, yeah, if for somebody who believes that there's galaxies, other planets out there, and probably other civilizations, I really do want to know what's going on every other planet in the universe, you know, and then what happens in the next universe, and then what is that universe inside, you know. It's basically like a story that never ends. One story could end, and a bunch more just begin, you know, immediately after it, you know. So that's something to think about. But anyways, you know, again, subscribe if you're not already. If you like these videos, let me know. If you have any more requests, something you want me to talk about. I like making these long videos for like science. But it's interesting to think about, you know. And so, and I have a Patreon too. If you want to donate to kind of make like these videos more possible, I promise you the money will go towards like the channel and all that other good stuff. Help it, you know, can kind of actually make me want to make more of these videos, so that way we can keep the ball rolling. But again, you know, thanks for watching, and again, have a wonderful day.